Hey everybody, welcome back. Hope things are still going well at home. And hi, hope things are still going well at home. I just want to join you in our series so that we can keep practicing with some of the things that are a little bit new. So today's topic is stem and leaf plots. Stem and leaf plots are really useful as a way to both display and organize data, but also as a cool way to kind of turn it into a visual but keep the data intact. So this is the sort of worksheet that's around this, and you can see that what they have is these stems. So let me tell you what this data actually says. It says we have the data points 65, 68, 70, 71, 71, 74, 77, and so on. So these are test scores. At the bottom, you can see this is 100 and 100 again. That's how they've organized this. And it's a really simple way to sort of organize the data in a little bit more compact of a form and a lot easier to read. So, like I said, you can also sort of see the distribution here. We have this sort of smaller bit here and then the curve. So that curve is really visual while also retaining all of the actual original data points. That's what makes these so useful. So in order to do this, we would find the maximum. So what's the highest number on this? Well, probably not surprisingly, the highest number on this is 100. It's hard to get higher than 100 score on a test, although not impossible. What's the minimum? Well, the smallest number is 6 and 5, so we have 65. The range is from the minimum to the maximum. What's the sort of size of that spread? So you would do 100 minus 65 and you'll find the range. Now, this goes back to our measures of central tendency. Mode is the number that occurs most frequently. Which number occurs most frequently here? Well, as I look down, for the 6, we have a 5 and an 8. There's only one each, so definitely not there. For the 7, I have 2 ones. That's my first contender. You would keep going through that and find which one occurs the most frequently. To find the median, we're literally going to start counting from the top and bottom. So we have 65 and 100, 68 and 100. And since these two are both too long, they actually cancel each other out pretty nicely. So when I look 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, these two, 7 and 9, cancel each other out exactly. So now I'm just going along the middle. 1, 2, 3, 4, 5, 6, and in the middle I have 8. So the median on this set of data would be 88. Finally, you have the mean. So to find the mean, you would add up all of these data points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 points. Add all of those up and take that final number and divide it by 21 because there are 21 data points. By the way, one shortcut for that is to make sure that you write down the number along the way because it's really easy to make a mistake and hit the wrong button and then you lose adding those all up. I actually tend to add them one row at a time, so I'd add 65 and 68 and make a little mark over here and then do the same thing for the next one. If I batch it that way, then if I hit one stupid key, it's not as much of an issue and I don't get frustrated. So that's this sheet. If I remember correctly, yep, this one is pretty. So when we get here, how do I create that? Well, the first thing I would do is put all of the data points in order and then start looking. For these single digits, we're actually going to use 0 as our stem. And so we'd have a leaf of 6 and 6 and 7 and 9 off of that. So you'll see if you can't make those. And I think, yep, that's as far as it goes. Oops. So that takes care of stem and leaf plots. Hope everything is going great. Okay. Tune in tomorrow for box and whisker plots. We'll get there, guys. Hang in there. Miss you already.